C'est bon, Doug, pour toi? Okay. Sorry, we diffuse the event online and Doug.
C'est bon.
It's okay? Perfect. Nice. Welcome. Bienvenue tout le monde à Montréal-Python 5.4. I'm Melanie. I'm a volunteer in Python Montreal and I switch between English and French. Sorry, my English is not perfect, but I tried. Je vais vous faire un peu l'introduction de l'événement et vous parler un peu de Montréal-Python. Voilà, on va être ensemble et ensuite on va pouvoir écouter les deux conférences. Just to begin, who are you? So, pour qui c'est la première fois à Montréal-Python? First patient in Montréal-Python. Nice, welcome, thank you to come in the first time. Over question. There are students, étudiants. Est-ce qu'il y a des étudiants? First, go, nice. Donc, vous êtes des professionnels dans le développement, après tous? OK. No, great. And qui parle français? Ah, d'accord. Nice. Je vais peut-être pouvoir switcher pas mal en français et anglais ou juste un peu. OK. OK, to both. OK. Perfect. Merci beaucoup. Pour les nouveaux, faire un petit point de Montréal-Python. C'est quoi Montréal-Python? C'est une association qui est depuis 2009 et on a retravaillé un peu sur notre slogan. Le but, c'est de se connecter, d'apprendre et de contribuer ensemble à Montréal-Python, donc au langage Python. Et pour ça, on organise des conférences, des workshops. Et on a une communauté en ligne, donc sur Slack ou sur LinkedIn et Facebook. N'hésitez pas à nous suivre sur les différents sociaux. Je fais ma manage social network. Ça nous fera plaisir de vous accueillir à nos événements. Les événements sont organisés que par des bénévoles qui sont un peu éparpillés partout. Je remercie Doug qui est un bénévole à la technique. Et si vous avez envie de devenir bénévole, to start to be volunteer, to help for, I don't know, video, organize the workshop, don't hesitate to communicate with us. For English, we have Bushra, if you want to talk about volunteer. And en français, vous pouvez venir me voir. So yes, that's it for Montréal Organization Volunteer. Et les conférences, on organise des conférences qui parlent de Python et on a 2 speakers qui sont aujourd'hui Robin et Andrew. Et on cherche toujours des speakers à chaque conférence. Donc, si vous êtes intéressé à devenir speaker et à faire une présentation qui touche à Montréal-Python, pareil, n'hésitez pas à venir me voir ou Bouchera. Ça nous fera plaisir de discuter avec vous et de peut-être venir là à ma place au prochain événement. Donc, voilà. Et les événements sont permis grâce à des sponsors. Et aujourd'hui, c'est Osedea qui nous accueille gentiment à l'événement. Donc, on les remercie beaucoup et peut-être qu'ils veulent dire quelques mots sur l'organisme. Ouais. Donc, c'est ça.
Bonjour tout le monde. Hi everyone. Merci de vous être présenté en grand nombre pour la soirée et les 2 conférences qu'on a à Montréal et Python. So thank you for being here in a great number for this Montreal-Python talk. So I'm Marie-Pierre. I'm the marketing director for Osedea. Mon nom est Marie-Pierre. Je suis la directrice marketing chez Osedea depuis un petit 3 mois. Donc, très contente de faire partie de cette belle organisation créée à Montréal en 2011. Donc, on est une firme d'innovation et de technologie donc, qui fournit majoritairement des services dans le domaine du AI, l'intelligence artificielle, de la robotique, de design de l'expérience utilisateur, UX, UI et de conception logicielle. So we're an innovation and technology firm who specializes in software engineering, UX, UI design, artificial intelligence and robotics. Et nous desservons plusieurs industries, donc pour en nommer quelques-unes, dans le secteur manufacturier, dans le domaine de la santé, dans la fintech également, finance, Donc, si vous avez également des gens qui recherchent un emploi, on a plusieurs postes ouverts en ce moment, donc avec une grosse croissance. Donc, n'hésitez pas à l'entrée, il y a un QR code qui vous amène directement sur notre page carrière. If you're looking for a job or know someone interested in working with us, we have a lot of open positions right now, thanks to our amazing growth. So don't hesitate to pass the word and please follow us on our LinkedIn page. Merci aussi de vous abonner à notre page LinkedIn. Vous allez avoir toute l'actualité, de l'information aussi sur nos projets et notre belle culture d'entreprise. Donc, je vais laisser la parole à mon collègue Cédric. I'll let Cédric have the stage to talk to you most about the career opportunities. Merci et bonne présentation.
Hello everyone. If I do it in English only, is it okay? It's okay. So, I think I didn't do it before. So yeah, just a technical point. I'm at Osedea for 6 months, something like that. I'm lead on the project. We are using Python. So just like Maria told you, we have open position, mainly seniors. Just for you to know, where we are using Python for AI, of course, you will see that we are using for Dot and Spot, so the two Boston Dynamics robots, and we are using Python also with Django as backend. And yeah, that's it. If you have any question, come after that. Check someone with the Osedea t-shirt and go. Thank you.
Super, merci beaucoup. Donc, encore merci de nous accueillir ici, dans ce super bureau. On remercie aussi notre autre sponsor, FGNR, qui est un sponsor un peu plus annuel, qui gère les serveurs et infrastructures de Montréal-Python. Mais si vous travaillez dans une compagnie, vous n'êtes pas de compagnie et que vous souhaitez devenir sponsor, believe sponsor from Montreal-Python, welcome. We search all time enterprise to host events or support Montreal-Python. And for that, you can talk about Noël in front of a place. N'hésitez pas à aller le voir si vous voulez des informations ou pour les personnes qui sont en ligne à nous contacter sur nos réseaux sociaux. Et la dernière chose que je vais vous présenter, c'est notre prochain event. Donc, celui-là n'est pas fini, ne partez pas, mais notez le prochain event. So it's in May 15, and Montréal-Python is hosted by NAD, l'École nationale des arts numériques, dans ce sublime bâtiment au centre de Montréal. So take a note, and vous êtes les bienvenus au prochain événement qui aura la même forme que celui-ci. Donc voilà. Je vais laisser ma place au premier speaker, Romin, et bonne conférence.
Okie dokie. I'm just going to start my timer so I can keep track, and we'll switch over. Oops. Perfect. Cool. Well, thank you so much for joining us. So today I'm going to talk to you about the Spot SDK. So I named it 101. It's a very, very shallow dive into the Spot SDK. So what is the robot? Well, actually, you know what? Before we introduce the robot, I'm going to introduce myself. So I'm Robin Kurtz. I've been a software developer for the last, for a little while, since 2014, so going on 10 years now. And the last 3 of which I've been working very, very closely with the Spot robot from Boston Dynamics as the Spot solution specialist, a fancy name on LinkedIn, but it really doesn't mean much. So today we're going to talk about a few different points. So first, who or what is Spot? Then I'm going to talk very, very briefly about Osedea and Boston Dynamics. And then we're going to talk about what is the Spot SDK. We're going to do a coding example, fingers crossed that everything goes well. And then if we have some time, we'll have some questions. If not, I'm around after our second talk that we can discuss a little bit further if we'd like to. Cool. So what is Spot? So for those of you who don't know what Spot is, it is a quadruped robot from Boston Dynamics. It is a very agile platform used to do various different tasks like inspection or data collection. It serves as a platform to allow developers to customize its capabilities. And the SDK, or the software development kit, allows developers to basically add different sensors or different components on the robot. So we'll see a little bit better when it's standing up afterwards, but the robot, the yellow part is the base robot. Everything above it are what are called payloads. So I'll touch on that just a little briefly, but basically those are sensors, onboard data collectors that can be changed depending on the use case. So that's basically the robot. It is a tool. It is a very strong, robust tool, but for today, it's just a fun toy for us to play with. So who's Boston Dynamics in regards to Osedea? So we're a Boston Dynamics business partner. So we're here to allow different businesses here in Quebec to test out the robot, see if there's good ROI before they go on and buy their own robot. Whether that is just some training, whether it's a 2-week POC, whatever it is, we're here to work with different enterprises to facilitate that kind of work rather than saying, okay, let's buy this big robot and then figure out what to do with it. We want to let people test drive the robot first and see if it's going to work for their use case. Cool. So what is the Spot SDK? The Spot SDK is made up of a few different things. So first is the conceptual documentation, so the key abstractions used by the Spot API. It's got a Python client library, so that's why we're here today. There is some stuff here that's more on the robotic side, but I'm going to try to bring it back to the Python because that's the main subject for today. So that client library is a lot of different things. It's an introduction, a guide on how to control the robot, as well as read sensor data. So as I mentioned earlier, you can put captors or sensors on the robot. So you could, with the SDK, you can read those sensors. But there's also sensors inside the robot, let's say like the onboard cameras or the battery temperature, that kind of thing. So the SDK allows us to cover all of those different things, and we can do whatever we want with it. There's also some examples and tutorials, one of which we're going to look at today. Then there's the payload ICD, which is the interface control documentation. So these hardware pieces are connected to the robot with this 25-pin port. That's all crazy fancy, and there's a lot of work to be done with that. So there's documentation on how you can basically develop your own payloads that go on the robot. Nothing prevents you from slapping on anything you want on the robot. The only limitation is about 14 kilograms of weight on the robot. So let's say you want to move a blender to make margaritas, something that Boston Dynamics did once, you could do that. You want to add an arm to it, a robotic arm, you can do that, whatever you want. Cool. Then we have the API protocol definition. So this is full of all the classes, all the definitions, and all of the ways to communicate to the robot in its language. So it's using protobuf for that, for those who are aware of that. And then finally, there's the Spot SDK repository, which is on GitHub. Unfortunately, it's not open source, but it's public, so anyone can take a look at it. Can't really do much with it, but you can look around at it, see the different examples that they have on there. So I posted 2 links there. I'm not sure if we're going to share these slides, but if not, they're very quick Google away, dev.bostondynamics.com or Boston-Dynamics Spot SDK on GitHub. Cool. So we're going to jump into the Hello Spot example. As software developers, we're all familiar with that Hello World example. So it's very similar to that. Before we jump into that, there are a few different prerequisites. So this is a little bit boring, but basically you need an Ubuntu machine. It could be Windows, it could be Mac OS, but we prefer Ubuntu. You also need to be running Python 3.6 to 3.10. So that is what is supported. Of course, you can do that in a virtual environment or a Docker container if you prefer. We prefer Docker containers. However, sometimes for simple scripts, we'll just go with a virtual environment. That's what we're going to do today. So by default, the robot gives off a Wi-Fi network. And I can connect to that. So I've got a secondary Wi-Fi card here, and provided I authenticate with its network, I can then ping this IP that we have in blue, and then I can communicate to the robot. So once I've established that connection, I can send commands to the robot with the Spot SDK, and that's going to prompt me for a secondary username and password authentication. I have those stored in environment variables right now, so the code that I'm going to be running later, I shouldn't need to type in the password. So I just want to make sure that that's clear. Cool. So let me just switch over to my terminal here. Is the size good? I think it should be not so bad. So first we'll do a ping of the robot. Je partage pas ce écran. OK. Pardon. Always technical issues, huh? Oops. Present. Share screen, entire screen. Go back to that. You think I practiced this, right? There you go. So I think we're good now. We're good. Awesome. So I'm going to ping the robot, which is that IP, and we can see that we are not getting. I'm missing an 8. Oh, look at that. See, we're good. We're paying attention. That's fantastic. I'm not even paying attention. Cool. So now we can communicate to the robot. So that's great. So now if I stop this, can I stop it? Yes, I can. I'm just going to quickly show you where I am. So it's a little bit hard to see, but we've got the Spot SDK downloaded directly onto my machine. We're in Python examples, hello Spot. And then what we want to do is create a virtual environment. So I have already done this, but I'll just, for the heck of it, I'll show you here. So we'll do pip and benv. So this is going to create a virtual environment, and then I will tap into that virtual environment, activate. And then here we can do a pip list just to show you what we have. So first we've got some Boss Dynamics packages. So this is the API, the client, the core, and a few other things. In this example, we're going to be dealing with an image. So we've got pillow as well. I'm not going to go too far into the other imports because they're not too important right now. So now that I've done that, I'm going to hit the command. So it's hello Spot. Let me just clear this first, actually. You can, it's very clear that I don't normally type on my keyboard. I normally have a fancy keyboard, so it makes life a lot easier. 8.3, so there you go. I'm basically just calling the hello Spot file with the IP or the host name of the robot. Oh, we got an error. Clearly my acting skills have proven that I knew that was going to happen. So what do we have? We've got an assert robot is eStop. Please use an external eStop client, such as the eStop example from the example. So let's go back to my presentation here. So we had a few different things. So first, we need an eStop. What is an eStop? An eStop is an emergency stop. Basically, we want to be able to have a way to say, okay, in an emergency, stop the power of the robot, turn off the motors so it doesn't hurt anyone. So that's step number one. Normally, you would have that from the tablet, which is going to be here. And we have a little, like a red eStop button. But because we're doing something from my computer, I need to establish this kind of a secondary script that's running. Secondly, I'm not going to dive too much into it, but I just want to point out there's a notion of a lease with the robot. Basically, you can only have one client connect to the robot at a time. So if I was connected with my tablet and then I ran this, even with the eStop, I would then get another error saying, oh, the robot's already leased. You cannot use the lease, right? Because we don't want to have the robot be, open to everyone. That being said, there is a way to force pull a lease, so that's a little bit interesting. But in any event, then, of course, before we're actually sending code to the robot, we probably want to know what happens, what we're doing. Sending code to a robot blindly doesn't seem like the best idea. So we're going to take a step back, and we're going to look at the code quickly. Cool. So we have the hellospot.py file. So we'll go through this pretty quickly. I don't want to bore you with too many of the commonality that we have with Python scripts. Of course, we have all of our imports. I find it a little bit verbose how they do it, but in any event, and we'll skip down to the bottom. So of course, we have our check to make sure that we're running this file directly and not importing the file, because we don't want to actually communicate to the robot unless we're really calling this script. So that's going to call the main script. And the main script is pretty simple. It's parsing the arguments. So in this case, this script will take in a -- save or a -- save path, and that's just for the image. So it basically allows us, do we want to save an image onto our machine? Do we want to save the image at a certain place? All these examples have their own different arguments, but that would be one way that we can kind of customize the script depending on how we're running it. And then finally, we run the hello Spot function over here. So we'll just go up to the top of the file. A lot of this is pretty verbose. Hopefully it doesn't feel too black magic, but we're going to try to explain a little bit. So first we set up some logging, just if we want verbose logging or not. Then we create an SDK, and we name it something specific for the task that we're doing. So in this case, hello Spot client. Then we create the robot with the config, which is basically that any of the options. So when we parse the command line, we create this object or dictionary of different options, and that's the config. So host name is that IP that I used earlier. Then we authenticate with the robot. So this line here on 49 is basically asking, okay, do I have the environment variable set? If not, let me prompt in the CI or CLI, sorry, to give me the username and password. Then we do a time sync. So for robots, it's very important that the computer and the robot are on the same kind of sync time, or else you can have some unexpected behavior. Then we have that assert that we actually saw here. So we're asserting that the robot is e-stopped. This will prevent us from trying to go a little bit further and realizing that we don't have a safe environment for the robot. Then finally, we've got some clients. So the robot, how the Spot SDK works is that there's a lot of different clients for different functionality they want. So the first one that we're seeing here is a robot state client. So we're basically just checking, okay, do I have access to the client in which to get the robot state from? And this is so that we can basically give it, we can get the current position and then do a transform to give it a different position or movement or that kind of thing. Then we have the lease client. So as I mentioned before, we only have that one lease. So if the lease were to be already pulled from another client, we would fail here. And then we're in a with loop to make sure that we're doing a lease keep alive. So we're making sure that, yes, we have the lease and it is alive, and therefore we can continue on our code. If we don't, then we'd error out. Then we've got a power on, and then we've got an assert to power on, a little bit of logging just for our own benefit. Then we have a blocking stand. So we just basically tell the robot to stand up. Pretty simple. So there's different util functions that we can use. Here we're actually grabbing that robot state. So we got the client earlier, but now we're actually getting the state. So the get robot state function is pulling the current position right now. So we can reference that for a little bit of a transform later. This stuff gets a little bit more confusing here. We're talking about geometry and movement positions. I find this a little bit more fun when we see the robot actually move. But this is basically create like a twisting motion with the robot. And then we create a transform or a trajectory of 3 different points where we get in the position, 3 different positions of the robot and basically loop over those different trajectories, and we send that to the robot. So here we've got some math helpers going on that creates this S3E pose. We've got quaternions. If anyone want to talk about that, Nicolas, my best friend here, has the best knowledge about that kind of thing. And then we create up these trajectory points, as I mentioned earlier. So there's a lot of verbose code. But it's just to kind of get you into the flow of how you would use the robot. Then we kind of combine all of the points as a list. And then we're using more functionality to basically send, okay, where is it? So here we have a blocking stand with our command client that takes in the body control, which has all the trajectory points in it. So it's very confusing. I apologize for that. But without actually visualizing and playing with the code, it's very hard to walk through. Then afterwards, we've got a simple image capture. So once again, we have another client called the image client, and that's going to allow us to get image from sources. So you can see this is a list of images. We can actually pass in multiple images. The body of the robot has cameras on all sides. So depending on what image I want, I can pass in a list of multiple camera sources or just one. And then this does a simple maybe display or maybe save. So without doing any fancy with the command argument, we're going to see the image on the screen once it's captured. Then we do an operator comment that's just more for debugging purposes. And then we power off the robot and we see you later. Any questions thus far? I know it's quite a bit of information. We just want to see the robot move, I imagine, right? Cool. So let me go over to my terminal again. And if you remember, we need to do that e-stop. So right now I'm in another terminal window and I'm in the e-stop example. So I'm going to do the same sort of thing where I'm going to source my virtual environment, and I can just check pip list. I've got very similar packages. I don't have Pillow anymore, but I've got PyQt5 for more of a GUI experience, but we're going to run it without a GUI just because it's a little bit simpler. So we're going to do Python 3 e-stop no GUI, and then pass it the IP. I really should have put the IP in an environment variable. Cool. So now I've got this e-stop. So now if I need to, I can trigger the e-stop and the robot's going to do an emergency stop. Awesome. So now we're going to go back into the other one, and we're going to just, can I not go on? There we go. We're going to rerun the command. So Python 3 hello spot, and then the IP. So now we do a start of the lease check-in. We're going to power on the robot. It takes a few seconds. Robot turns on. Robot stands. Robot does a twist. So that's that little trajectory that we spoke about. Sorry, this is the trajectory. So basically we gave it 3 different points to basically go up and then down. And then we have a photo, which is unfortunately it's of Carl taking a nice photo. Great pose. We're going to save that one for sure. I like that. Wait, no, I got to save it. Sorry, this is more important, clearly. There you go. Okay, we're going to. Cool. So there you go. So that was kind of exciting, I hope. So next what we're going to do is we're going to actually run some custom code, and we're going to hope that it works. Because of time, I've pre-written some stuff. So before just running it, I'm going to just show you a quick little diff of the file. So I've got a hello Spot and a hello dot. You'll see the little name tag. This is dot. Our other robot over there is called Spot. That was the original one. So in here, we're going to just show you what I've added here. So I've done a simple import where I've imported block for trajectory command. And then I've created a function called move spot. Move spot's pretty simple. It's probably not the best way to actually move the robot, but it's a pretty simple one. So basically what we do is we're once again using that robot command builder, which I sort of skipped over. I apologize for that. And we do a synchro velocity command where we give it a Vx, a Vy, and a Vrot. So what is that? Well, if we go back to my presentation quick. So this is the orientation of the robot we can see. So forward roll, or kind of like a roll in this axis like this, is our X. Or going forward would be our X, right? Our pitch or our Y is going to be going to the left or the right. So depending if it's positive or negative value, it's going to go to the left or the right. Same with the X. If it's positive, it's going to go forward. If it's a negative one, it's going to go backwards. And then we've got our Z or our yawn, which is going to let us do different things. So for this case, since we're just dealing with a simple move command, we're going to just play with the X. So I'm going to go back to my code here. So this is going to take in those different variables. What does the V mean? Well, it's a velocity. So we're giving it a velocity value. And then we're giving it a end time in seconds to our robot command. So basically what we're doing is we're giving it velocity and time. Velocity times multiplied by times gives us distance. So that should give us about a distance. I'm doing a 1 second time. So in theory, any of my velocity, we should get that amount of distance. Now I will say it's not super precise. This functionality is not for that. So it might actually go a meter, but it's going to try. So we have that defined. After that, we've got a block for trajectory command. So that just says, okay, run the robot. Does it work? If it doesn't work, or if it doesn't happen in the allotted timeout we give it, then fail gracefully. So it will basically prevent us from moving on until that action has moved, until the robot has moved. And then finally, we just have it calling it down here. So what I'm going to actually do is I'm just going to comment out this movement stuff just because of time. So I'm just taking out the whole twist and turning part. And we're going to save that. Go over here. And we're going to rename for dot. And we're going to see if it works. Fingers crossed for me, please. We have the robot standing. Oh, there you go. So that wasn't a meter, I don't think. But there you go. The robot walked. So that was pretty simple. And we can even see we took a different photo, same lens, but a different frame. So just proof that the photos aren't fake. There you go. So that's that part. Let's jump back into my presentation. So just so you're aware, I've kind of filled out some slides for that part that I've explained just in case if we had an issue, I would be able to go with the slides, and if for people that see the presentation later. So now we've commanded Spot. Of course, this is a very rudimentary example of what we would do with the robot. You could do a lot more cool things. Like I said, there's the SDK that's full of different examples. If you're interested in at all, I'd say definitely go look at it. Unfortunately, we won't be able to actually play with the SDK because you don't have a robot for yourselves, but maybe in a few years, we'll have lots of robots or lots of spots or dots walking around, and then you'll be prepared for it. So yeah, thank you so much. We have time for some questions, maybe? Okay, so good. We have 5 minutes for questions. Anyone? Yeah, we got a question back there.
Yeah, so I'm surprised that the SDK is so low level. Is there any, it feels to me like TensorFlow, but what I would like to have is like errors. So like just saying get up or walk 10 steps, or like steps as an argument. Is there a developer for that? Or?
Yeah, it's a great question. So I think from my point of view, the SDK is pretty a wide range. So we do have utils like blocking stand that just stands up the robot, where you could do something like that. That being said, there isn't no walk X steps. They deal with more about velocity. That being said, we could easily create a util to do that. But you can also do a lot more complicated things. Boston Dynamics also has released a bit of they've kind of teased at the fact that there's going to be a new API where you can actually control the different joints. So at that point, you'd actually get a lot finer grained functionality with the robot. So there's a bit of both in there.
Regarding the code that you have shown, does the code only work on this robot, or can it work like on another type of robot, for example?
So it can only work on a Spot robot that is running the Spot platform. That being said, I could run it on that robot without any change. Really, I just have to basically it's the IP and then the network that I'm connected to. So if I'll connect to that network, I'll have the same IP. I can just send it to that robot, and it's going to do the job.
Yeah. Maybe one quick question. And if we want, like, let's say for example, I want to play a bit with the robot. Do I need the robot, or can I is it like a virtual robot online, something along those lines?
Yeah, so out of the box, Boston Dynamics doesn't offer any kind of virtual playground, unfortunately. It's something that I was really shocked about when I first saw it. I do know that there's some companies that have done their own kind of thing internally, so I wouldn't be surprised if there's something at one point, but it's definitely something that they lack. I will admit. Yes.
Is there a existing kind of localization, implicit localization and object avoidance and built into the platform? You don't have to necessarily instantiate all of that in addition to that.
Yeah, that's it. So out of the box, the robot is using its depth cameras or its IR cameras on each side to basically create a point map. And it's also using that to avoid the obstacles. So if I were to walk it again and stand in front of it, it would in theory walk around me. That's also comes into play about it actually being a meter or not. Its localization is very tied to its current position on boot up. So it's got its world frame, and then that transform is from there on. So it's not necessarily doing a callback to check to see, okay, did I really move that distance? So you have to build that in as well. But yes, obstacle avoidance is already built in, but it's also an option. So you could turn it off and have the robot walk into something if you wanted to. Yep.
Do you have some companies in Montreal that are already using the robot for their purposes? Would be great to hear the purposes.
Yeah, for sure. So the robot at the base is really an inspection tool. Out of the box, you have this tablet that you can register an auto walk mission. In this auto walk mission, you start at one place. We have a fiducial or a QR code that kind of localizes the robot. It could be on a docking station as well. And then you tell it, okay, go over there, take a photo. Go over there, take a photo. Go over there, take a photo. And that could do an inspection in your facility. So let's say with this thermal camera payload that we have, we can take a photo of a motor, see if the motor is running too hot. We can take an audio snippet and see if there's a bearing clanking noise, that kind of thing. So it depends on the use case. We've done a few different projects. Most of the projects that we're working on right now are more up north in mining and other industrial facilities like that. The benefit of the robot is one, when it's repetitive and kind of dull. So dull, dirty, dangerous, and dear are the 4 Ds of robotics. So any job that kind of fits into that is one. The dangerous aspect is another one, right? So like if it's a mining facility, if there's a lot of toxic stuff in the air, there's the Ontario Power Generation. In Ontario, of course, they have robots that have Geiger, not calculators, but counters on them to see if there's radiation leaks. So there's that aspect as well. We did a project with the STM where we're kind of taking the robot to evaluate the current cleanliness of a metro station, looking for graffiti and that kind of thing. So there we deployed a computer vision model to detect, is there graffiti on the wall? Is there stickers on the wall? Is there garbage on the ground? And that kind of thing. Yes? No, sorry. I'm going back. I'll come to you next.
Just want to know if we want to perform important learning on this, the code that you showed, what would we add on to that code, that robot, instead of just stopping when the command goes wrong, it just runs something, adjust, and make adjustments, and then perform the task.
So out of the box, there's nothing with the base functionality, because the robot itself is very user friendly in the sense that you don't need to be a software developer to actually use the robot. That being said, if you want to code something that has some sort of feedback loop, you can certainly do that. So there is one case where we could run code that basically checks all of the cameras, looks for a human, and then does an action based on it. So basically it follows the human. So with that sort of logic, you could build out something that would do a certain task in a certain context, if it's seeing something or sensing something or whatever. I don't know if that answers your question. maybe it was.
Yeah, kind of, but I'm more curious to know like how reinforcement learning and robotics.
Oh, reinforcement learning. Sorry. Yeah. So actually, Boston Dynamics just came out with a blog post on the reinforcement learning. I think that they're a little late to the game. I'll be honest. I've seen a few other companies doing this for a while. That being said, we don't know how long they've been doing it for. But they are working with the robot, and that kind of goes into what I was mentioning earlier about the new API where you can control the different joints. So with reinforcement learning, the robot isn't just what it could do now. Right now, it walks 5.4 kilometers per hour. But with reinforced learning, you could basically open up all of this much more useful, or I shouldn't say useful, but dynamic robot that can go up over a much bigger height, can run a lot faster. So it's really at the at the beginning for Boston Dynamics specifically.
And basically, the companies use Python, all the companies together, right? But the code can be shared and stuff like that.
Well, I think I wouldn't be the best person to comment on this, but I think Python is pretty well used in that space. There's also C++. So Boston Dynamics does have a SDK in C++. It's a lot less built out than the client one. That being said, the actual Spot SDK is very specific to the robot. There's also Rust, Rust that would also be used. There's a company called ClearPath, which is a Boston Dynamics partner. They built kind of like an abstraction to use Rust on the robot as well. So it depends on what you do. So they are kind of doing their own thing for sure, but there is some overlaps with other companies.
Yeah, but when we see the videos and somebody posting on LinkedIn,
Yeah.
they see robots doing a lot of stuff. So perhaps there's a lot of going into it, and companies might not want to share what they are using and stuff like that. But
That's exactly it.
Python is open source language, and people are using it, and they are sharing code and locally on GitHub.
Yeah. We'll see. We'll see where it goes.
Thanks so much.
You said that your program is based on velocities and around. Is that the same thing for inspections? If you're sending it to the same machine, you have to give it a path.
Yeah, so basically you give it a path, but like I sort of mentioned, it's super user friendly at that point. You don't need to be coding at all to do basically a basic inspection. You take the tablet and you say, okay, let's register from here, and then you control the robot with a joystick. You tell it to go over here, you tell it to give it an action, and it basically just records that. Then that gives us an auto walk mission file that could be uploaded to the robot, and then that could be scheduled on a cron job or any sort of scheduling system. So in that case, you don't have to worry about the velocity aspect of it. The robot is going to self-adjust. If there's an object in its path, it's going to go around the object if it can. If it's really blocked, well, then you can basically tell it sit down or go back home. You can basically program it to do what you want. But at that level, it's more settings. Yeah.
Geolocation.
There's no geolocation, so it's basically using a point cloud off of its cameras. So at the base, it can see about, I think, 2 meters around itself. But then we have this payload, which is a LiDAR, that gives it up to 100 meters of recognition. So it can create a point cloud understanding of the world, and it basically checks that versus its initial one that it did on registration.
But you could give it like a geolocation
You could.
point
For sure.
and say go to that point and it would find its way.
Yeah, exactly. So out of the base, it would use that point cloud logic. So provided you have a map and you have a LiDAR or a point cloud map kind of overlaid onto that 2D map, you could give it go over there type of thing. That being said, you could also build something else that's using some sort of beacon or a GPS or that kind of thing as well. Yeah. I saw a hand over here. Yep.
Most of my questions have been answered. One remaining is whether your SDK is specific to the geometry of the robot. In other words, in particular velocity and displacement axis and frame of reference. And also, this makes me think about the actuators and the sensors that you've incorporated into the robot. First of all, are they all provided by the same? I see several vendors there. Boston Dynamics. How sensitive are these actuators and sensors to going out of range? Do you have any redundant sensors? Or
you know what? I'll stop you there just because there's a lot of questions that we don't really know the answers to. The robot itself is very black box. Even with the SDK, the best thing we can do is get like all of the current joint information. There are limitations. So let's say if I try to give it a different position that's outside of its physical properties, it's going to error out on me. So the SDK itself is very specific to the robot, and I wouldn't know exactly what all the redundancies are with the different joints. I do know that there's a lot of safety checks. Like if let's say I cover one of the cameras, it's going to let me know, and it's going to have degraded perception and then you'll be limited on certain things you can do. So it's a very safe, robust robot. They've been working on it for years, so I would imagine there's probably some redundancies as well in there. And if there are issues with any of the joints or that kind of thing, it'll let you know, or it won't even let you, use the robot depending on how bad it is. Yeah.
Okay, so if the robot goes out of the range of its physical parameters, is this automatically an unhandled exception, or have you developed recourse for that?
It's a handled exception, so it'd be up to me as the developer of that script to basically handle that and do something else with it. But I could intercept that error that it gives me and be like, okay, do something else.
Thank you.
I saw another arm, I think.
Yeah.
Last question.
Last question.
Well, it's gonna be quick. I wonder how much it costs.
Yeah, great question. Everyone wants to know that. So at the base, just the yellow part itself is about 110 USD. So it is quite expensive. However, in the right context, doing the right job, it brings back that money quite quickly. All of the hardware that we see on here, which I'll go over very, very quickly, is closer to 300,000 Canadian. So we got a thermal camera, which can basically show you a heat map of everyone. Oh, sorry, so there you go. So we got a heat map of everyone. In case everyone has a fever or whatever, I can use that. This is acoustic imaging. So basically, it's a camera inside and then microphone. So it will basically do a color map of audio or sound that we as humans can't hear. So let's say you have a compressed air leak in a facility. Well, you can capture it with this, and then you can do something about it before wasting all that money on compressed air. And then this, like I mentioned earlier, is that LiDAR, and then a modem to allow us to do 5G and LTE connection with the robot. And then underneath is a GPU and CPU combination to do any of our custom scripts. So we can run TensorFlow, we can run YOLO. I run YOLO on that all the time, as we wish. So it's pricey, but it's fun.
Yes.
Thank you so much.
That's 7.
Okay, perfect. So, you're okay? You just need to change this and switch.
Okay.
Just that's it. Okay.
Dot's going to be a hard act to follow. Hi, welcome to my talk. My name is Andrew Francis, and the name of the talk is Pardon the Interruption, prototyping a kinder, gentler interruption mechanism for a voice assistant. Well, the purpose of this talk is to prototype a form of interruption for a voice assistant that doesn't involve necessarily terminating the intent. A lot of voice assistants are really hard to, when they start to talk, they're just really hard to stop. And we're going to get into that subject. So some of the things we're going to touch on in this talk are Dialogflow, ES, Essential, Google Assistant. Actually, how many people know what Dialogflow or Google Assistant are?
Some people over there.
Okay. Basically, Google Assistant, well, there's two forms. Google Assistant is the hardware, essentially the hardware. There's also a software component to it. Dialogflow is a Google product that's used for building voice assistants. There's two flavors of it, ES and CX, but just keep in mind that Dialogflow is used for building, for designing voice. It's used for designing and implementing voice apps. And for a while, it ran over Google Assistant. The next thing is Python sound device library. It's essentially a shim over port audio. We're also sort of we're not really going to so much get into Python threading, but it's there.
And last but not least, there's this area called conversation analysis, which we will get into quite a bit. Now we'll get on to the motivations. Well, for the past few years, on and off, I've been developing a voice application. The application's very simple. All it does is it manages your library books by voice. So I could tell it, hey, what's out? And we go, well, Andrew, you got this, blah, 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 blah out. Great, renew them. So at one point, I wanted to add something called progressive response. We won't quite get into what progressive response is. So anyway, I wrote Google Dialogflow support. Hey, how would I do progressive response with Dialogflow ES? And they tell me, hey, Andrew, yeah, sure you can do progressive response. You just have to implement a custom integration. Going back to, I said a Dialogflow works on top of Google Assistant. Well, in this context, Google Assistant is considered an integration. In general, that is what an integration looks like. And they said, oh, just implement one of these. I went, whoa. So this essentially means you have to implement the input yourself. You have to implement the output yourself. Also, the little piece that's called your client app, depending on the sophistication of the integration, there's either very little happening in there or there's a heck of a lot happening there. For the most part, and by the way, what's really important to note here is this is essentially full duplex. A lot of not even voice-enabled apps aren't really, I wouldn't call them full duplex. You press a button, you talk, you press a button, then the response comes. So this is full duplex. And the folks that tend to write these sort of custom integrations are telephony companies. There's this other part that's cut off called detect request and the detect intent and detect intent response. So this is an API call that allows you to stream audio to the cloud. And what it will do is it'll return back the intent and entities. And So anyway, just to prove that actually is. So anyway, here's something very important. When I talk about prototyping, I don't want to call what I'm doing an integration. I typically call it, for now, just think of it as the runtime. This is the only piece of the runtime that I have not incorporated, because streaming detect intent is a part of it is a generator, and it's just ridiculously implemented. See that little global called done? That's really crazy, because here's the other part of it, where the first part implements the generator, and the other part, this is the generator. And for weird reasons, you have to set done in this loop to tell the generator to terminate, or else you don't get the final output, and I asked the Google engineer about that, and he said, well, yeah, Andrew, that's a bit crazy. So it actually works like that. So this is the only piece of code that's actually not implemented in the runtime that I'm developing. So anyway, let's move on. The second motivation was, in late November 2022, I was listening to a talk given by the Conversation Design Institute called How should conversation design deal with interruption? And it's given by 3 people. So 2 of them are academics. I forgot from which university in England they are. But the third person is, actually the second person, Elizabeth Stoiko, I guess she's an authority on conversation design. And the last person, Kathy Pearl, served I think she's the head of BART or whatever it's called right now at Google. And she's famous for this book called Designing Voice Interfaces. So anyway, they're giving this talk and they're using something called conversational analysis to basically describe interruptions. And they mentioned this paper in passing. When I first saw it, I went, okay, this is interesting, but as a developer, I really don't know what to do with this. I was hoping that this talk would actually tell me how to implement interruption. Then a few months later, I revisited the talk, and I just decided to read this paper. It's got a long-winded title. And the paper would talk a lot about stuff like turn allocation. And it sort of gives a conceptual framework for analyzing conversations. And sort of like the core of it is turn taking. But I saw this word turn allocation and I looked at some of the rules and a little light bulb went off. Gee, turn allocation? Gee, this is a lot like an operating system scheduler. And then we're off to the races. And I would say the big ideas from that paper, and it's a really dense paper to read, but it's got some big ideas there. And it's sort of concerned with the notion of turn taking between two or more speakers. And they sort of implied that there are rules. You could describe conversations with a set of rules. Rules and conversations have certain characteristics. One of them is usually we talk one at a time. There may be a little bit of overlap. But they're really, or at least the early conversational analysis papers, from what I can gather, they're really interested in the structural aspects of a conversation, regardless of culture or what's actually being said. Another part of conversation analysis, and I'm sure if I was in a conversation analysis course, they'd probably give me a D- for notation, is you have this notation. And you notice this open bracket, open bracket here. That denotes that someone was talking and they were interrupted. Also, you see this 0.5 means 0.5 of a second passed. There's much more notation, but we're just going to use this for now. Also, you notice at the end, I just said assistant and left a blank. I'm going to ask you a question. Pretend this is your voice assistant. It's just renewed your book. You've asked it, like, how many books renewed? It answers back. By the way, a lot of voice assistants don't support this form of interruption. They tend to just terminate. But what's interesting is, I'll add as a side note, Alexa, if you're running Alexa with voice, if you're running Alexa with audio, playing music, you actually could stop it, say, hey, what time is it? It'll give you it will turn down the music, give you the time, and then resume. But it's really ad hoc. Well, actually, it's really inconsistent what voice assistants do there. But here's this other part. So after the assistant has answered, half a second has passed. What do you think the assistant should do next? How many of you think it should just resume reading the loan receipt? How many of you think it should ask, do you want to continue listening to the loan receipt? Okay, you're about half-half. In general, when I ask people that, they're split. So anyway, this is not necessary to understand how I'm going to implement this kind of general form of interruption, but what really comes out of conversation analysis is the conversations are described in terms of term construction unit. A sentence could be a term construction unit. And then there's these transition relevant points. That's where, like, I'm speaking, I've sort of stopped what I said, and it's your turn. And usually the theory, well, it's arguing that we tend to want to minimize these gaps between when one person stops talking and another person starts talking. These gaps are small. They're measured from tens of milliseconds to about 300 milliseconds. The papers give it or take, but roughly, this is like 50 years of research, basically says that regardless of culture, the gaps tend to be small. A gap of 1 second is often an indication that something's wrong. It's like, hey, can you lend me 50 bucks? And then the person, there's a gap of a second, something's up. So in regard to voice assistants, you probably really want to minimize your response time. You want to be fast. So anyway, there's a really nice passage in that talk where Kathy basically says about interruption. You should expand your mind, your imagination, and think what would make sense. Okay, and the rest of this talk I'm going to take her up on that one. So anyway, the example we're going to walk through, you basically saw it already with that. We're going to, that's okay. In the talk, I'm going to do something different from that talk. I'm going to walk through what I think a pragmatic example is. So in this example, your voice assistant's reading a long passage. In the previous one, it's a loan receipt. It could be a book. It could be a SEC filing, doesn't matter. You're asking it you interrupt it by asking it short questions. How many more pages are there? How much more time will this take? Doesn't matter. You're just asking it short questions. And you don't want it to necessarily terminate, because you may say, yeah, okay, keep on reading. The CA literature refers to this type of interruption as relationally neutral interruption. In that, it's sort of like, it's a fancy way of saying, this is not a power move. I'm not interrupting you to assert my authority over you or humiliate you or anything. And then we get into a field of like cooperative overlap and cooperative interruption. But anyway, so let's build. So I say, well, let's build a system where the voice assistant is built on top of a special component. I don't have a good name for what I'm doing. I don't want to call it integration. Let's just call it the runtime. And let's assume that a major responsibility of the runtime is to enforce turn-taking rules between two or more speakers. So with the voice assistant, I'm a speaker, the assistant is a speaker, and two or more speakers. And we'll assume that turn-taking is akin to process scheduling in an operating system. And again, we basically have two important speakers. Because I had library books in my head, I call the humans the patrons and the assistant. The patrons tend to make the requests, and the assistants either do they respond to the requests, or occasionally they may prompt the user for additional information. And we'll make the assumption that the runtime can differentiate between speakers. It can identify them. So in the runtime, a conversation generates events. And we're just going to say there's two important events. There's when you start talking and when you stop talking. And speakers can also register interests in events. Basically, the speaker that wants to register an interest is the voice assistant. We're going to assume that there's priorities. This is a fancy way of saying if the speaker talks, if the patron talks, they get priority. And then there's these other things that if there's a prompt, it gets priority, then responses, and then weirdly enough for this system, the timer. Timer's treated as a speaker, but a low priority one. And then we have rules. And a rule can be based on anything the runtime knows about. So maybe we have one voice system where we don't allow you to talk for more than 2 minutes. Or you can't have more than 3 or 4 back and forths. Could be anything about that it can glean from the state. And a rule could be, well, yeah, it could be we only have one speaker at a time. The patron always initiates a turn. And the speaker can interrupt another speaker based on their priority. It's just a fancy way of saying, I can interrupt you. This is an interesting one that I threw in. It's not clear if the speakers know the rules of the system. So again, let's call these this is not a part of CA literature, but more involved for what I'm doing. Let's call this set of rules a regime. And in this simple proof of demo, we only care about the following attributes: who's speaking, the message type, and time. Another thing is the patron can issue new requests before a responsive previous request has finished. This is just a way of saying we're going to support a form of multitasking. So now back to that long-winded should a voice assistant interrupt. One part of that talk they say, well, let's try to define interruption. Okay, fine, we'll define it. Basically, interruption is one speaker's act of talking causes the current speaker to stop talking. But we don't assume that this necessarily terminates the underlying process. It's like a pause and a resume for music, but we're generalizing it for everything that the voice assistant says. We now know that this is not this is not generative AI here. It's me drawing. So to tie this all together, this is essentially the stack. And you can see that Sound.io will be used for generating the audio. The turn taking is really the main component of what I'm developing. And then there's the ASR, which is, for now, stuff from Google. TTS stands for text-to-speech. And then at the top is really your voice assistant, which that's where the high-level dialogue's done in the domain logic. So this thing has a scheduler. Now we're going to dive into the API. We're just going to deal with the core scheduler. So you see the scheduler takes an event. It could be like a speaker is talking. And it does its magic and it returns a tuple. It basically says, you should stop. You have permission to start speaking. You should stop speaking. There's some helper functions. Raise hand, lower hand, ask for permission. Basically, in the code, you'll see when the thing wants to talk, a speaker wants to talk, it will literally raise its hand and lower its hand. So let's just walk. This is more about the scheduler state. So we care about the candidate. That's the person that's asking for permission. Current is who's currently talking. There's a ready list of people who are basically, you've been paused. There's another thing that we're not really going to use right now called wait for event. So in this simple case, that the current speaker is the candidate's the assistant. No one's speaking, so it goes ahead and starts emitting audio. And just to prove that there's some code there, you take a look at this and you can see message start. If no one's speaking, I become the speaker. I absolutely love the match statement. I use it all over the place. It's just gorgeous. So anyway, here's another case. The candidate's the patron. So a human starts to speak. The assistant is droning on. So what happens is the patron becomes the speaker. The assistant is shoved on the ready list, and basically the scheduler says to the patron, stop speaking. And we won't actually get into the mechanics because this is already a long talk. Yeah. So we're going to shift gears. Processes don't like being interrupted in general. They may be in an inconsistent state. For example, if I did the audio, what would happen is at one point you'd hear "and neuro," and then when the human's talking, and then when it resumes, you'd hear "mancer." What's happening is in the audio buffer level, neuromancer may be between two different audio frames. But this is a detail way down here. Yes, we can fix this. And there's library, but you have to, yeah, we can fix it. But if there is another issue, it begets the real issue. But we're just talking about the output of this. The voice assistant, yes, it's outputting. But it's also doing calculations itself. It's processing. When you interrupt it, what are you doing to the underlying transaction? That may be in an inconsistent state as well, and you have to do something about it. But that's outside of the scope of this talk for now. So anyway, in conclusion, the takeaway that I want is, on the one hand, we have this thing called conversational analysis. But, we can take some concepts from computer science, and it really helps our understanding of how to implement stuff like this. And after all, at the end of the day, suspending and resuming processes is a pretty well understood problem in operating system design. However, by implementing this stuff, the assistants themselves really go up and they get much more complex. Thanks. Yeah, I'll add one other thing about the scheduler itself. It's actually based on who's heard of Nous? It's an operating system by Douglas Comer. It's one of these operating systems in a book used for teaching kids about operating systems. So anyway, any questions? Yes.
I can't help but think of a friend that designed intentionally, as a joke, kind of intentionally designed a version of Tetris that is intentionally malevolent toward users called Hatris. I'm curious as to whether or not the thought has occurred at any point in maybe the back of your mind, making something that does turn taking in a malicious fashion and tries to interrupt. No? Okay.
No.
Well, I don't know. That would be fun.
Okay. Yes.
Yes, two questions. Have you worked on the possibility when you have your end tuple? I was thinking you're mentioning one criteria for ordering the priority of the speakers. I was thinking now if you have patron assistant, you have another one, the topic of discussion also becomes a second part of that end tuple. And further on, have you worked on ways of conflating the various, convolving, I should say, the various parameters to give anticipated outputs? The other thing that I'm thinking of, striking me, when you're introducing.
Actually, can we work on the first one, one question at a time? So what you're asking is, how am I determining the priority?
We have multiple parameters for determining the priority. Have you worked on that particular solution? And what sort of complexity have you encountered? Okay,
this is a prototype. Unfortunately, it would have been too hard to do a demo, but for now, I'm keeping it, as I said earlier, I'm keeping it very simple. I'm basing priority simply on your role, essentially your role. Are your role and the type of messages. A future version, like if you basically subclass the scheduler, you could come up with new criteria. So that's the way I would answer that question. I'm trying to keep things very minimalist because this is a proof of concept to see if it works. I don't know if that answers your first question.
I think you'll answer it in a future presentation, Pat. Now, let's move to the second question.
Yes.
Very well. When you're introducing turn-taking the runtime, when you're introducing the prompt for the interrupt, you're introducing a non-linearity in the human response. So ultimately, you're changing the course of the conversation. In a sense, one would want to try to minimize. You mentioned minimizing. You're putting, how do you say, bounds on the pauses that can be interjected. But would there be also ways of using machine learning, and I think there are, to anticipate the interruption of the course or the possibility of interruption, so that the impact on subsequent interactions is minimized? Because these nonlinear effects, if one has to wait when you're introducing delay in the system, that can propagate and change the course of the conversation.
Okay, I think
on that type of reasoning.
I think there's a lot to munch on there, but I think a part of it is maybe I should tell you what a prompt is. Don't mistake them with LLM prompts. Mm-hmm. A prompt is actually something quite simple. At some point, the agent may be saying something. Well, you can choose from the following colors. Red, yellow, orange, green, and it goes on, and you say, well, I want red. That would be an example of a prompt. So that's what a prompt is. I don't really see where that's injecting non-linearity per se. However, yeah, I'm having a hard time munching on it.
Okay, I understood the prompt as some sort of signal or some sort.
No, just asking a question. It's nothing more mystical. Although there are issues with interrupting prompts, but again, if I went through that, this would be a 1-hour talk. Maybe a future version, I will talk to you about the logic of interrupting a prompt, because interrupting prompts are interesting. Because you can have the case, well, choose from the following colors: red, white, blue, yellow, pink. I want that one.
Okay, I understand. I misunderstood. I was thinking more like you have some sort of round table discussion, and there's an actuated light that prompts people to change change the.
Okay, I'll add something. No, this is something that's actually in the back of my mind. Actually, more than the back of my mind. This is a proof of concept, but if your underlying ASR could actually identify the users, you can imagine a group discussion where a voice assistant is the facilitator. And it says, well, little Timmy, you've been talking too much. Let Rebecca have a turn. We're entering a world where you can actually build systems like this. So those scenarios are in my mind. And they're almost technically doable with stuff off the shelf. That's maybe another thing that may not quite be here. In this little stack, I don't know if it's showing. Right now, the ASR is Google, the NLU is Google, the TTS is Google. But I could just as easily now swap that Google TTS out with an Amazon one or a Microsoft one. There's tremendous choice in text-to-speech. For that matter, which I probably will do because streaming detect intent drives me up the wall, I may find another ASR. So we're entering a world where you can mix and match components. And things like I said with the facilitator, we could probably do that. Little bits and pieces of that are here now. I believe there's co-pilots that, during a meeting, the co-pilot will just create the transcript and summarize it. So all this it's here.
Thank you.
Okay.
Juste 2 minutes. C'est vrai que je voudrais vous partager les prochains événements qui concernent du Python.
Yeah, to say that next week we have software crafter. It will not be a normal software crafter. We will have 2 speakers. One, it will be at Osedea also. One will be one with a different type of prog between Python and Go. And the second one will be about computer vision, and it's still in Python also, done by Nicolas here. So if you are interested, we open inscription 1 week, so tomorrow. It will be 9 p.m. Thank you.
Where do we do the registration? On Meetup?
Meetup, yeah. Software Crafter Montreal.
This is a special edition?
Yeah, special. So normally we have open discussion and things like that. This one will be with presentations.
And Nicolas will be there or he's on vacation?
He will be here.
Okay, and of course.
Merci beaucoup, on va finir là-dessus. N'oubliez pas Montréal 105 in 50 May. We create a meetup event during the week, and thank you to come. Merci.
Well, thanks for having me.
And thank you for you and